I realize that showing you how to do these examples by hand is something I know you've been taught already, but it never hurts to remind you. So if you need a reminder, here you go. Solving an equation that has a square root in it, we always want to be thinking, well, what's being done to the variable? I need to get to that variable, and if the variable has a square root on the outside of it, how do we undo square root? Well, undoing square root means squaring. Squaring a square root means we basically are canceling out the square root, and what is left over when we square the left side is just x minus 2, and then when we square 3 we get 9. So you got to be careful when you take the square root or when you square something that you check your answers, because sometimes squaring both sides of an equation you add in an extra solution and we get something that we don't need, and we get an extraneous solution. Anyway, we're going to check that, but before we do that, we're going to add 2 to both sides. Adding 2 to both sides, we get x is equal to 11. So getting x equals 11, we want to check that. Check. And we get 11 minus 2, square root, does that equal 3? The square root of 9, yes, equals 3, check. So yes, 11 is our solution that makes the original equation true. Well, let's try to do that on the calculator and see what we get. Remember, the left side is our, let's clear out the last thing there. The left side is the square root, and that's second x squared. So square root of x minus 2. So the left side is our y1. The left side of our original equation is our y1. The right side is 3. And just like always, we want to do zoom 6 for the standard viewing window. And sometimes the standard viewing window shows us the solution, sometimes it doesn't. Standard viewing window, just to remind you, is from -10 to 10 in both directions. Well, if that doesn't do it, you at least get an idea perhaps of what the graphs, or where the graphs might intersect. And it looks like we need to extend the viewing window from in the horizontal direction. So we need to make the x a little bit bigger. The y was fine, but the x needs to be a little bit bigger. Let's let the x go up to 20, and we'll leave the y's alone. So when the x goes up to 20, we started the x at 0 and went up to 20, and again the red line indicates that y is equal to 3, that y equals 3 is constant. And so we want to figure out, okay, we see that we already know that it's going to be 11, but we want to act like we haven't done this by hand already. Many equations that you solve you're not going to be able to do by hand, so you have to be able to do this only by using the calculator. And just like always, we want to find where they intersect. So we're going to hit second calculate, number 5, and that brings us to this screen. And since we only have 2 functions input, notice that it's asking us to input what's the first curve. Well, the first curve is listed there, y1. The second curve is already marked there, y2, and so we're going to hit enter again, and then we're going to move the cursor somewhere near it. There's only one point of intersection, and when we hit enter, we see down there in the lower left-hand part of the screen on the calculator that x is equal to 11, and that's the solution of our equation.